Good morning, dear friends. Today we'll be starting with real numbers. The video that is uploaded will give you an idea of family of numbers. It's a quick revision for family of numbers. In 8th standard, we have already learned about rational and irrational numbers. So in this lesson, we'll be basically dealing with rational and irrational numbers. First of all, let's start with the rational numbers. The symbol for rational numbers is Q. Rational numbers are all the numbers which can be written in the form P upon Q, where Q is not equal to 0 and P and Q belongs to integers. That means all the fractions comes under rational numbers. But when you solve fractions, you must have seen in 8th standard we have solved fractions. When we solve fractions basically, when you solve them and get it in decimal form, the decimal forms sometimes turn out to be terminating kind. For example, 3.45. This is a terminating decimal number. Otherwise, sometimes the decimal number comes out to be terminating recurring number. For example, 5 upon 27 recurring, which looks like 5.2727 and so on. So this is a terminating decimal number. This is a non-terminating recurring number. And then we have also learned about non-terminating non-recurring numbers, which look like, for example, 0.24785103425 and so on, where there is no particular pattern observed in repetition of numbers, but the decimal form does not stop. It is non-terminating non-recurring. So we call it NTNR. All those who were there in my class last year, they must be knowing the short form that we used for non-terminating non-recurring was NTNR. These are non-terminating recurring numbers, NTR, and these are terminating numbers. So in 8th standard we have learned that terminating and non-terminating recurring numbers, these both numbers go in rational family. They are in rational family. And the NTNR, that is the numbers which are non-terminating and non-recurring, and also numbers like root 2, root 3 and pi. These all numbers come in the family of irrationals. They all fall in the family of irrationals. The symbol is Q complement. The symbol for rational numbers is Q. So basically, Q and Q complement together form the family of real numbers. So Q and Q complement form the family of real numbers. So if at all basically you want to remember this family, you can remember in this way. Real numbers being the father has two sons, that is rational and irrational numbers. Rational numbers have all the numbers which can be written in the form of decimal. Let it be integers, let it be naturals, let it be whole numbers. These all numbers can be written in fraction form. Whereas irrationals are those numbers whose decimal format is NTNR, non-terminating, non-recurring, and also those numbers whose roots are not perfect. The roots of non-perfect squares, root 2, root 3 or root 5, these all are non-perfect squares, 5, 2, 3. Their square roots come under irrational numbers. And also a very famous number called pi. Pi also comes under irrational. So this is a brief idea of what we'll be learning in this lesson. We'll be learning about real numbers, rationals and irrationals. Rationals basically consist of whole integers, naturals, whole numbers. These all come under rationals, and irrationals are all the numbers which are non-terminating, non-recurring. So after dealing with this, we'll be seeing the next. We'll be starting with the first exercise. In the first exercise, that is exercise number 2.1, before starting with the first sum, for solving the first sum you need to know one thing. Whenever you have a fraction, for example 22 upon 5, this number 22 upon 5, the denominator, if the denominator prime factorization is having only 2 or 5 as the factors, when you factorize, let's take another example, 21 upon, for example, 10, 21 upon 10. So this 21 upon 10 can be written as 21 upon 10 factorization is 2 into 5. So the denominator when factorized gives you 2 into 5, and if the factors are only 2 or 5, either 2 or 5, then the decimal number, when you solve it, the decimal form of this fraction will be in the terminating format. It will be in terminating format. But if you have another number, for example, take 25 upon 14. This 25 upon 14 can be written as 25 upon 2 sevens. Factorization of 14 is 2 sevens. So if you'll observe, the prime factors are 2 and 7 apart from 2 and 5. Other than 2 and 5, you have 7 over here. So this decimal number, that is the decimal form of 25 upon 14, will be non-terminating recurring. It will be non-terminating recurring. So this is one method by which you can find out whether the decimal form is terminating or non-terminating recurring. And this is what the first question of exercise 2.1 is. Exercise 2.1, the first question says that you have to find out whether the number is terminating or non-terminating recurring. So let's see the first number. The first number is 13 upon 5. Now if you'll observe, 13 upon 5 is having 5 in the denominator. That means what are the factors? Either it should be 2 or 5. Remember, it should be 2 or 5. So we have 5 as the prime factor. That means this number, the decimal form of this number will be terminating. It will be in the terminating format. Okay, so you can write the answer. The decimal form of 13 upon 5 is in terminating type. Question number 2, 2 upon 11. Now 11 is already a prime number, you cannot factorize it further. And how to solve this sum? The factors should be 2 or 5. So if you'll observe, the denominator is neither having 2 neither having 5. It's having something else, other number 11. So the decimal form of this number will be non-terminating recurring. It will be non-terminating recurring. So you can write here, the decimal form of 2 upon 11 is non-terminating recurring. Now let's go to the next number. The next number is 29 upon 16. Now the denominator 16 can be written as 4 4s are 16. That is not prime factorization. Divide 4 further as 2 into 2. So it can be 29 as 2 into 2 into 2 into 2. This is the prime factorization of 16. So it will be 29 upon 2 into 2 into 2 into 2. Okay, so this will be, if you'll observe, the factors are supposed to be 2 or 5. So we have here all 2 as the factors. So this will be a terminating type. Remember children, it should be either 2 or 5 or 2 or 5 both. Then it becomes a terminating kind of a number. Okay. Now the next number. Let's see the next number. The next sum, question number 4 is 17 upon 125. Now 17 upon 125. You need to do prime factorization of 125. 125 will be 5 into 25. Correct? 5 into 25 gives you 125. Further it can be written as 17 upon 5 into 25 is 5 into 5. So if you observe, the factors over here of the denominator is all 5. So that means this number, the decimal form of 17 upon 125 will be terminating. Now let's go to the fifth sum. The fifth sum is 11 upon 6, which can be written upon 11 upon 2 3s are 6. So if you'll observe over here, the factors are 2 and 3. But we need the factors either 2 or 5. If it is 2 or 5, then it is terminating. If it is apart from 2 or 5, then it will be non-terminating recurring. It will be non-terminating recurring. So the decimal form of 11 upon 6 is non-terminating recurring. Okay. Now question number 2 of exercise 2.1. Question number 2 of exercise 2.1 is very simple. It's basically division. You have to do division. The first sum says 127 upon 200. You have to write decimal form of 127 upon 200. That means you have to divide 127 by 200. So what we'll do over here is 127 upon 200 can be written as 2 in 200. We'll do little wise calculation over here. Instead of blindly doing 127 divided by 200, what we are going to do is we will write 200 as 2 in 200 and we will divide only 127 by 2. 127 divided by 2. 2 6 are 12. 2 3s are 6.0. 2 5s are 10. So when you divide 127 by 2, you get the answer 63.5 upon the 100 still remains. We did not solve for 100, so 100 remains. Now in lower class, that is in 6th standard, I suppose, we have done that whenever we divide by 100, the decimal shift towards left, and when we multiply by 100, the decimal shifts towards right. So here we are dividing by 100, so the decimal is going to shift towards left by 2 places. Since 2 zeros are there, so 2 places, 1 2. So the number will be 0.635. So this is the final answer. This is what they are asking us to do, to find the decimal form of this fraction. So you have to do division and get the answer. Okay. So let's do question number. I'll leave some sums for homework for you all. So I'll try question number 4 over here. Question number 4. 4 upon 5. 4 upon 5. Again this is division. 4 upon 5 is division. So we have to do division over here. 4 upon 5 division. So let's divide 4 by 5. 4 divided by 5. Now 0 point. When you put 0 point, you get a 0 over here. 5 8s are 40. Done. The answer is 0.8. So this is how you have to solve the second question. You have to write the decimal form of the given fraction. Let's solve one more question. Now question number 3 is 23 upon 7. Now 23 divided by 7, again plain division. 7 3s are 21. 2 down, 0.0. 7 2s are 14. 6 down, again 0. I think this will be a non-recurring number. Let's take a bigger space and let's start solving. 23 divided by 7. 7 3s are 21. 2.0. 7 2s are 14. 6. One more 0. 7 8s are 56. So 4 down, again 0. Then 7 5s are 35. 5 down, again 0. Then 7 sevens are 49, 1, again 0. 7 ones are 7, 3 down, again 0. 7 fours are 28, 2 down. See, you get 2 over here, that means the division is again going to start from here. You'll put a 0 here and the division will again keep on repeating. Okay, so you'll be having again the number 2 over here, then again the number 8, then again number 5, then again 7, then again 1, then again 4. That means this is a recurring number, 3.285714. This full thing is going to recur, it's going to repeat. Okay, this is a recurring number. Okay, now let's start with the next sum, question number 3. In this exercise, question number 3 is important. Question number 1 and question number 2 is basic, which you will be easily able to solve with some help, and this video will help you to solve the sums. We'll see question number 3. Okay, now question number 3 is we have to express recurring numbers in decimal form. We have to express recurring numbers in decimal form. They will give us a recurring number, and that recurring number you have to express in decimal format. Okay, so let's start with one example. Let's take an example. If we have 0.6, I'm taking example from the textbook only. Question number 3, first sum. Question number 3, first sum says 0.6. This we have to express in the decimal form. Okay, now remember children, this sum is very important. Okay, it's very likely to come in the exams also, so pay attention to the steps. The first step will be, we'll be calling this number as x. Okay, so suppose this is our answer. Now our answer starts. So the first step is, we'll call this number as x. Let x be 0.6 recurring. Okay, now the second step is, you have to observe that how many numbers are recurring over here, whether one number is repeating or two numbers are repeating or three numbers are repeating. If one number is repeating, then you multiply by 10 because it's having 1 0. If two numbers are repeating, then you multiply by 100 because it is having 2 zeros. If three numbers are repeating, then you multiply by 1000 because it is having 3 zeros. So if you'll observe here 6 is repeating, that means one digit is repeating, so we'll multiply by 10. So we multiply 10 on both the side. Here 10 will multiply with x, and here 10 will multiply with 0.6 recurring. So this will become 10x, and when you multiply 10 with 0.6 recurring, let's view how 0.6 looks. 0.6 looks like this. Okay, and when you multiply 10, the decimal jumps towards right. Okay, so when you multiply this number by 10, the decimal will jump towards right, and the answer will be 6.6666 and so on. So this will be the new number. The decimal will jump and come over here. Okay, so the new number will be 6.6 recurring after multiplying 10. Okay, now what we are going to do is, we will call this step number 2, and we will call this as step number 1, the x step. X step will call step number 1, and this step will call step number 2. Now what we are going to do is, we are going to do step 2 minus step 1. That means 10x. Step 2 is 10x minus step 1 is x, is equal to, on right hand side, step 2 is 6.6 recurring minus step 1 is 0.6 recurring. Okay, so 10x minus x will become 9x. 10x minus x will be 9x. Now let's see what happens when you minus 6.6 recurring minus 0.6 recurring. See, this is 6.6 recurring. 0.6 recurring will be looking like this. It will be like this. When you minus it, all the 6 minus 6 minus 6 minus 6, everything will become 0 here. And 6 minus 0 will be 6. So you will be left with 6. So here you have 6. So 9x is equal to 6. So if 9x is equal to 6, that means x will be what? 6 upon 9. This 9 will come over here. 9 is multiplied, 9 will come over here and get divided. So x final answer is by the table of 3. 3 2s are 6, 3 3s are 9. So the final value of x is 2 upon 3. Okay. So this is how we solve this sum. This is how we are going to solve this sum. Let's see one more example. Let's see when there are two numbers repeating, then how to solve this sum. Okay, let's see an example in which when two numbers are repeating, then how to solve this sum. For example, question number 2, 0.37 recurring. Now let's see 0.37 recurring. Step number 1, you call 0.37 recurring as x and call it as step number 1. Step number 2 is you have to see how many numbers are repeated. Here 37, 37, 37 is repeated. That means two digits are repeated. So if it is 2 digits, that means you should multiply with 100 because 100 is having 2 zeros. So 100 multiplied with x and 100 multiplied with 0.37 recurring. So 100x and this 100 multiplied with 0.37. See, 0.37 recurring looks like this. When you multiply 100 with that, the decimal jumps towards right. 1, 2. Decimal will come over here. So the new number will 37.37, 37, 37, 37 and so on. So the new number will be 37.37 recurring. This will be the new number after multiplying 100. Call this step number 2. After this, step number 2 minus step number 1. Step 2 minus step 1. So step 2 LHS is 100x minus step 1 LHS is x is equal to step 2 RHS is 37.37 recurring minus step 1 RHS is 0.37 recurring. So 100x minus 1x, 100 minus 1x, answer will be 99x. 37.37 recurring is written over here minus 0.37 recurring. That means it will be like this 0.37, 0.37. So when you minus this number, you will get 37 minus 0 is 37 and after decimal all will become 0. Right? So the answer over here will be 37. So you have 99x is equal to 37. That means x will be 37 upon 99. Now 37 and 99, if they are going in same table, you cancel them. If they are not, let them be as it is. So x is equal to 37 upon 99 is the final answer. Now what was x but what we took x as? X was 0.37 bar. So x is 0.37 bar is equal to 37 upon 99. Put it in a box and the answer is done. This is how we are going to solve these sums. Okay. Now let's see one more question in this exercise. Question number 3 I leave for you all to solve it as homework. I'll help you with question number 4. Okay, let's see question number 4. Question number 5. Let's solve question number 5. Question number 5 is 2.514 recurring. 2.514 recurring. Step number 1. Let x be 2.514 recurring. Call this step number 1. After that you have to observe how many numbers are repeated. 514. 3 digits are repeated. So if it is 3 digit, that means you should multiply with 1000, because 1000 is having 3 zeros, and the same 1000 you will multiply on the other side. So 1000 into 2.514. See, 2.514 looks like this. 514, 514, 514 and so on. When you multiply it with 1000, 3 decimal jumps happen. 1, 2, 3. So decimal comes over here. So the answer is 2514.514, 514, 514 and so on. So the answer will be 2514.514 recurring. Answer of 1000x. Okay, call this step number 2. Now you have to do step 2 minus step 1. Step 2 is 1000x minus step 1 is x. Step 2 RHS is 2514.514 recurring minus step 1 RHS is 2.514 recurring. Okay, now 1000x minus 1x. 1000 minus 1 will be 999x. 1000 minus 1 will be 999x. And let's do 2514 minus 2.514 recurring. It will be like this. 2.514 should be written like this, decimal one below the other. 2.514 minus, this will be 4 minus 2, 2, 1 down, 5 down, 2 down, point. 5 minus 5, 0, 1 minus 1, 0, 4 minus 4, 0 and so on. So the answer over here will be 2512. So x will be 2512 upon 999. So before finalizing the answer, before saying this is the final answer, you need to first check whether these numbers are multiple, like going in some same table or what. For example, let's check table of 3. 5 plus 2, 7, 8, 9, 10. This number doesn't go in the table of 3. So 2512 upon 999. I think this number is not going in any of the table. If you'll keep checking for table of 3 or table of 7, some prime number, you need to check for some prime number. You'll get whether it divides 2512 and 999. Not divisible in any of the number, I suppose, after checking. So we can finalize the answer. X is equal to 2512 upon 999. X value was 2.514 is equal to 2512 upon 999. This is the answer for question number 5. Okay, now we have completed with exercise number 2.1. After exercise 2.1, children will be solving root 2 and root 3. In 8th standard, we have already learned how to draw root 2 and root 3 on the number line. So your homework for today will be, you have to solve all the sums of exercise 2.1, which I solved on the board and also which I left for you all to do. And after that, you will be drawing root 2 and root 3 on number line. This is already done in 8th standard, so this is a revision for you all. Drawing root 2 and root 3 on number line. Okay, now in 8th standard we have also learned drawing root 2, root 3, root 5 on the number line. So for your homework, you can add root 5 also over here. I want you all to draw root 2, root 3 and root 5 on the number line after this exercise. So this will be your homework for the week. Okay, so see you in the next week, children. Revise this exercise nicely. We'll meet on Wednesday. Okay, see you and God bless you.